We'll talk briefly here about requirements and test, and we'll talk more about this during the project discussions on Fridays. But how do you know your code is correct? You write requirements, and then you write test cases to test against those requirements. And there is a lot that goes on there. You know, there are entire courses built around developing good requirements and test cases. This is just a basic introduction, and like I said, we'll go into this in more depth on Friday. Writing requirements. Now I'm going to say requirements. Technically they're requirement specifications. Requirements are what the software should do, or what the system should do, and then the requirement specification is specifying these in a formal or written down way. And the bottom lines that we'll hit over and over again here are: number one, they shall be concrete. They cannot be ambiguous. You have to define correctness. You can't say the program shall correctly calculate the volume. You have to define what volume is. You can't say the program shall do things quickly. You have to define what quickness is. If you want to say that the program shall respond within 1 second, that's a little bit more concrete, right? Within 1 second. Okay, so between 0 and 1 second, that's good. If you want to say the program will respond in exactly 1 second, that's not going to work, because nothing is ever exact. 1 second plus or minus 10 milliseconds. Many of you have taken mechanical engineering drawing, and you know you never put a dimension down without a tolerance. So if you're going to put a dimension down, put in a tolerance. If you know that you can calculate things perfectly according to a formula, then you don't need the tolerance. You're describing the functional behavior. So what's not included? The GUI interface shall be attractive. That's not functional, nor is it measurable. The GUI will be easily understood. That's not functional, nor is it measurable. Each requirement shall use the word shall. Shall is a legal term. You will see some authors differ on this a little bit, but shall is the standard. It's not should. How do I fail something that should? The software should do this. Well, it didn't. Oh well, too bad. I still passed because it should have, but it didn't. You know, it's shall. I've got an additional set of notes that I'm posting with this. And we'll talk through those on Friday. And you can also use the examples that are given in the homework assignments. So we try to create the examples in the homework so that you can go back to these and look at them. The software shall correctly compute the package software surface area SA. Now how can I get away with that in a requirement? Because I have defined SA using a formula prior to this. The software shall correctly compute the package surface area SASI. Once again, formula. I'm defining L, W, and H. That doesn't mean those are the variable names. These are the variables that are used in the formula. That doesn't mean those are the variables that are used in the actual software. I tell what the units are. You can look at the homeworks, you can and you can get a good feel for what a requirement should look like. A good question when you're writing a requirement is this: can I cheat the requirement? If I was dishonest, could I cheat the requirement? And often when students are writing requirements, you know, that's how I'm going to approach it. I'm going to talk to you and say, oh, I can cheat that requirement. You know, it's not a good requirement. If you can cheat the requirement, it's not a good requirement. Once you've created all of your requirements, now you need to do test cases in order to test the requirement. And you will have multiple test cases per requirement. This is one of the reasons I'm not asking you to write an entire complete requirement specification for your project. It's too much work for one person in one semester. I am asking you to write some requirements in order to get practice doing it. And when you go to SE 300, you'll do a lot more of this. Notice we're not writing code yet, right? But the trick here, or the goal here, is you have everything so well nailed down prior to beginning to write code that writing code is fairly trivial. It should be the easiest part of the process. All right, once we have requirements, we're going to test them. How do you write test cases? The thing that's hardest for me to get students to understand is that they must be concrete. You can't say, oh, I'm going to test a sorting routine and I will put in 5 numbers. That's not a test case. Put in 3 numbers. That's not a test case. Put in 3, 5, and 7. That's a test case. And then you need to consider different ways that you can test things. If you have an if-then-else branch, you generally want to test the Boolean test in such a way that you get the true branch to activate and you also get the false branch to activate. You may want to have test cases where you're putting in deliberately bad values and proving that you can handle the bad values. Maybe you're doing your exception handling testing. Students tend to think of their software as working. You tend to think of, okay, I'm going to test it when it works. Here, all of my test cases are based on the assumption that it works. And I'm only going to test those cases to make it work. But you really might want to include test cases where it shouldn't work and convince yourself that you've handled those test cases. And the reason is the first user that comes along is going to do something that you didn't think of, put in a negative value for a radius of a circle, and your whole code goes kablooey. Well, maybe you should have tested what happens when you put in a negative value for the radius of a circle. Even though nobody should ever do that, even though you think logically your code is bulletproof against it, well, if you think your code is bulletproof against it, prove it. Test it. Maybe when someone puts in a negative value for the radius of a circle, they get a warning message and the radius is set to 0 under your set radius method, and you can test that. As a general rule, and I'm saying user input, user input, user input, you can avoid user input in your test cases, and here's why. In order to have user input, you have to have working code that actually has a working GUI interface, and you're too far along at that point. You own the software. You're creating the software. What's user input going to do? If I have user inputs 12, isn't that going to be assigned to an attribute or a variable somewhere? So why not just create a method that sets that attribute to 12? I don't need a user. You create all of the code. You are the God of this universe. So if you need that attribute value to be 12 in a test case, don't input it from the console. Write a method that sets the value to 12 solely for testing. Create methods in your code solely for testing. And one of the good things about that is when you need to rerun tests, it becomes a lot easier. You can even create a method called test. Create a whole class just called test cases, and then it basically builds your code and then injects all your tests automatically. That's actually a tool inside of Eclipse. I am not requiring it in this class. I'll make you aware of it. It's called JUnit testing. When you go through the Eclipse tutorials online, they actually start out with JUnit testing. It's a little bit more effort than we need to do in this class. You've already got enough to do already. However, if you want to use JUnit testing, by all means feel free to, and I'll help you when I'm able to. I have had students use it in the past, and by the end of the semester they were very happy people, because all their testing happens literally with the press of a button. But you can effectively create the same result by creating methods that are used for testing. Oh, and by the way, since you have to show me in your documentation that you did testing, you have to show me in your code that you did testing, what a great way to document it. Hey Garfield, here's the code. Look, there's all the test cases. I generally say don't comment your code. However, commenting with a big bright comment that says here's where I did my test case is probably a good idea in terms of grading. What are the formats for the test case? Well, each test case should be there to support a specific requirement. So I'm giving you this format in the P3 template. Each one should support a requirement, so you have the requirement ID and then the test case ID. By the way, I recommend that you number your user stories 1, 2, 3, 4, 5, 6, and then if you have a requirement for user story 4, let's say you have 3 requirements for user 4, I would say that's 4.1, 4.2, 4.3. And let's say you have 3 test cases for requirement 4.1, that should be 4.1.1, 4.1.2, 4.1.3. That way you can easily number your test cases, and you have what we call traceability. You know that that test case came from requirement 4.1, and that requirement 4.1 came from user story number 4. Anyway, requirement ID, test case ID. Initial conditions and inputs. These are everything you need to know in concrete values to set up the test. Expected output or behavior. Concrete values for what the program should do. If it doesn't do anything on the screen, surely an attribute value changed somewhere. Surely a method returned a result. That's what you put there. So that's your expected stuff. Now in P3 you're only going to do these because you don't actually have actual code yet, so you can't actually test it. But by the end of the project you have set up all of your tests, and then you can run your code and run your tests, and you get the actual behavior, and then you can determine pass-fail. It is not a requirement in this class that you pass all of your tests, other than there's a small amount of points given to code correctness. It's more important to do the test. If you do the test and fail, that's fewer points off than if you don't do the test. Okay, we'll talk much more about this on Friday, and I'm sure we'll talk much more about it as we develop P3.